So this is the second graph that you see on that worksheet you just got from the substitute. Looking at this, you can tell that the amplitude in this case is only going to be 1. And the reason is because the highest wave goes up to 1, the lowest wave goes down to -1. The midline, just like the last, is y equals 0. The midline is the x-axis. All right, next thing we're going to look at is the frequency. This is definitely a change from the last problem. So in 2 pi, the parent function makes 1 complete revolution. So just to sketch in what the parent function looks like, it looks something like this. This one definitely makes more complete revolutions. So we can see our first one here. So this is 1 complete revolution, 1 complete cycle. This is the second one. So that's 2, and then 3, and then 4, and then 5. So the frequency here is 5. The period of one of these cycles is no longer 2 pi. It's actually going to be 2 pi divided by 5, because remember the period of the parent function right here is 2 pi, and we just need to divide that equally among the 5 shorter waves. The last thing that we need to talk about, let's see, I've got my midline, I've got frequency, period, amplitude. I need to think about a phase shift. And so just like our last one, there is no phase shift here. So we could say none, or you could say 0. The reason I know that is because the general look of this wave is that it goes up, down, up. It looks exactly like the parent sine function, and therefore there's no phase shift. So at this point, we can write the equation y equals, remember the amplitude goes first. The next thing that happens after the sine is the frequency, so the 5 will go next. X minus our phase shift, which is 0, plus our midline, which is 0. So it looks like a challenging equation. More simply, we really could have just written y equals sine, and then in parentheses 5x.